All right, we're diving into Module 4, and so many of the 7th grade standards deal with rates, ratios, and proportionality, and that's what this whole module is about. So this first section, 4.1, is on unit rates, and you've done some of this before. Please make sure you have your calculator handy, okay? And go ahead, get your notes out, and let's get this essential question, which is the same as what is worded at the beginning of this module, written down. How do I find and use unit rates? Okay, so as you get that down, let's get some of this identified and the vocabulary cleared up here. A rate. When you are perhaps in Phi-Ed, or if you've ever been on, say, a treadmill or something like that, you often can measure what your heart rate is, and that's measured in beats per minute. So what I like to say here for rate is that it is a ratio. And remember, a ratio is like a fraction, or it's a comparison of two numbers. Comparison of two numbers. And the big thing here is that you have different units. I am going to get in the habit of almost always writing it as a fraction, okay? Although there are a lot of different ways and notations you can use. But for example, like 70 beats per 1 minute, okay? Or let's say we do something like this. If I am driving and I drove up to visit my mom, it's 220 miles, and I can do that in about 3.5 hours, like that, okay? That's what a rate is, miles per hour, beats per minute, dollars per ounce, things like that, okay? Unit rate is simply a rate that has a denominator of 1. So a rate with denominator equal to 1. It's a long word, where the denominator is 1. So for example, this one right here, 70 beats per 1 minute, okay? Or if my car gets 34 miles per 1 gallon. Per gas mileage, miles per gallon. Notice that you see this word per a lot. That's where your fraction bar is. That's the dividing mark, okay, to tell you which number goes top and bottom, okay? Complex fraction is a fraction with either decimals or fractions in the numerator or denominator. So I'm going to say a fraction with decimals or fractions within it. I'll just say in it. Okay, so here would be something like this would look. So maybe I kind of did that in that miles in 3.5 hours. But if I had something like 1/3 of a mile in 0.25 hours or something like that. Okay, so you have a big fraction like this, and then you have fractions and or decimals inside of it. Woo! Thankfully, we have calculators that will help us out, or we can talk through it so that this would make more sense. All right, here we go. All right, so let's take a look at this first example. You're hiking, okay? Actually, not you. Jeff and Lisa are, all right? And so it says Jeff's rate here, he's hiking a 1/2 mile every 15 minutes. And if you think of a clock, okay, like this, 15 minutes is from here to here. That's 1/4 of an hour, okay? So let's stop right there because they're going to go on and talk about Lisa. But this particular diagram is really illustrating Jeff's rate, okay? It says use this bar diagram to determine how many miles Jeff hikes. All right, so every quarter hour, he's going a half a mile. So here's a half a mile. That's in that first 15 minutes. Then it's going to be another half a mile. Actually, I'm going to write these on top because I like thinking of it this way. Miles per hour, okay? Half a mile in a quarter hour. Here's another half mile in a quarter hour. Here's another half of a mile in a quarter hour. And another half of a mile in a quarter hour. So let's add all this up here, okay? So on top I have 2 halves make 1 whole, 1 whole. That's a total of 2 miles. And quarter hour, that's a half hour. Bloop, bloop. And then another 15 minutes or quarter hour. And another quarter hour. So this gives me 1 hour. So it says how many quarter hours are in an hour? Well, there are 4 of them. Those are those 15-minute chunks. How far does he hike in 1 hour? He hikes 2 miles. Okay, the picture can help you out if you can make sense of all of those fractional rates or parts. Okay, so here they're just asking us, let's go ahead a half a mile, and then notice on the bottom they're adding the quarter hour. That gives you a total of a half hour. Here we're going to keep adding. We're going to add another half a mile to give us 1 mile. Then they added another quarter mile to get to 3/4, which means I'm going to have 1.5 miles. Adding another quarter mile gives me my full hour, and that gives me a total of 2 miles. Now be careful here, because this is not following this same pattern. I kind of don't like the way they just jump here. But now, if he can go 2 miles in 1 hour, how far can he go in 2 hours? Basically, we're doubling this one. So to be consistent with his rate, we're going to double this one to be 4 miles. Okay? Now, let's talk about Lisa. I've got to jump back here to look at the original. Okay? It says Lisa hikes, and I even goobered all over it here, so let me erase a little bit. Lisa hikes a 1/3 mile every 10 minutes. Okay, now when I'm thinking of the clock, 10 minutes, that would be 1/6 of an hour, because I'd have to have 6 of those 10-minute chunks to total an entire hour. So now let's do the same thing with Lisa's rate. Okay, I'll change color here. So every 1/6 of an hour is 10 minutes. Okay, so I don't like that box there. Okay, it said she went a 1/3 of a mile. Okay, a 1/3 of a mile. Here's another 1/3 of a mile. When I add those together, that's 2/3. When I get this next 1/3 of a mile, that gives me a total of 1 mile. So at this spot right here, she has hiked a total of 1 mile. And then we get the same thing happening again. Each one of these is 10 minutes. Okay, I'm going to get a 1/3 of a mile, a 1/3 of a mile, a 1/3 of a mile. There's another 1 mile. So I get 1 mile here, another 1 mile here, which means she is hiking 2 miles in 1 hour. 2 miles in 1 hour. I could write it as a rate this way. That's her speed or her rate. It says complete the table here now for her hike. I'm going to put this little squiggle bar here. Okay, so add a 1/3. Actually, I have to put it here. Ugh. Add a 1/3 here. That's this next one. Or I should say add a 1/6 here, add a 1/3 up here. This is 2/3 of a mile. When I add 1/6, add a 1/3 of a mile every 1/6 hour. Add another 1/3 of a mile here, and we end up with 1 whole mile. Adding that next 10 minutes gives us a half hour. 1 mile in a half hour means 2 miles in 1 hour, because I just double this, double this. How far would she go in 2 hours? Double it again. Double the time, assuming she's keeping a constant rate or speed, times 2 here, times 2 there, gives me 4. Alrighty. How would you find Jeff's distance for 3/4 of an hour? Think about that for a bit. How would you find Jeff's distance for 3/4 of an hour? Did we have that in there for him? Sure. Here's 1/4 of an hour, 1/4 of an hour, 1/4 of an hour right here. So simply add up how far he went. Because if he's traveling a 1/2 a mile every 1/4 hour, that would be 3 of these. So he should have 3 halves, which would be 1.5. Okay, how did you find that? Well, we just kind of added 3 1/4 hours to find the distance. That was his time, and knowing that his speed, he was going a 1/2 a mile each time. So it would be 3 1/2. So we're kind of multiplying here, 3 1/2 miles. Which hiker walks farther in 1 hour? Jeff went 2 miles an hour. Lisa went 2 miles in an hour. So guess what? Even though they're hiking what appears to be different rates because of the way they gave it to us, they're actually walking at the exact same. So I'm going to say neither of them. They have the same rate. They're both 2 miles in 1 hour. 2 miles in 1 hour. All right, let's look at the next one now, and let's get into some of these. While remodeling her kitchen, Angela is repainting. She estimates that she paints about 55 square feet every 1/2 hour. Stop right there. I'm going to write this as a rate. 55 square feet in 1/2 of an hour. How many square feet does she paint per hour? Well, just think about this. I would need another 1/2 hour in order to get to 1 hour. So in a sense, what I'm doing is I am multiplying or doubling the denominator. And to keep the same rate, you have to do the same thing to your numerator. 2 over 2 is really 1 in disguise, so I'm not changing it. Or think of adding another one like we did in that chart. Here's a 1/2 hour. She does 55 square feet. Another 1/2 hour. She does another 55 square feet. When I add those two together, we should end up with 110 square feet per 1 hour. This is a unit rate because the denominator is 1. This is a rate. It's not a unit rate yet. Okay. Now, well, I don't know if I want to show you that yet. So let's just keep going. All right, Paige. Paige is mowing. They have a huge place out in the country, and there's a lot of grass to mow. So she's on her nice riding lawnmower, and she can do 1/6 of an acre in 1/4 hour. Stop right there. 1/6 acre per 1/4 of an hour. Think of your clock. 1/4 of an hour is 15 minutes, okay? So what is her unit rate? How many acres does she mow in 1 hour? Well, if this is 1/4 of an hour, you would kind of need to have 4 of them there, okay? 1, 2, 3, 4. That would give me a full hour. In other words, I'm kind of thinking multiply by 4, all right? That means you have to do the same thing to the top, multiply by 4. So I would get 1 hour in the denominator, multiply 1/6 times 4 on the top, and I get 4/6 of an acre. Don't stop there. That's not in simplest form. This is 2/3 of an acre per 1 hour. Now, I want to show you something. Because remember, we often talk about that division symbol or the fraction bar as division, right? I want you in your calculator, grab it right now, and first put in the fraction 1/6. Okay? I want to move it out. Now mine is super tiny, but you can kind of see it. All right, 1/6 divided by, okay, 1/4. I don't even know, frankly, if your calculator will let you do a complex fraction this way, but I just used the divide sign. And notice right away I get the fraction 2/3. When you just go ahead and divide these two right here, 1/6 divided by 1/4, you're going to get the value that goes in the numerator, okay? And now it's turned into a unit rate where your denominator's 1. If you hop back here and take 55 divided by 1/2, you will get exactly 110. When you go back here and take 1/3 divided by 1/6, you'll get 2. But what I need you to understand is that it's a unit rate with a denominator of 1. That's what these complex fractions are all about. All right, let's talk about Greta. She likes to cook. She's channeling her inner Italian meal here now, and she's going to be super chef. She's using 3 ounces of pasta, and that makes 3/4 of a serving. So this is the dry pasta, whether it's linguine, fettuccine, spaghetti, I don't know what. So 3 ounces, okay, makes 3/4 of a serving. Now, how much is that? How many ounces are in 1 serving? Well, to try to get this to be 1, we'd have to do some fancy math here and just kind of start thinking of a table. You could kind of go this way and say, well, if I doubled this, then I would have 6 ounces. That would give me 1 1/2 servings, because that would be 6/4. And that means if I doubled this again, I would have 12 ounces. That would give me double this, 3 servings. And then you could simplify. Now you could say, oh, 12 ounces for 3 servings. That would simplify to 4 ounces for 1 serving. There's my unit rate. Now, I just talked that through, thinking of doubling until I got to some whole numbers in my numerator and denominator. That makes sense. You, however, can use your calculator right from the get-go and say, what's 3 divided by, that's that fraction bar, the per 3/4. And when we do that, let me get this pen back on. Remember that dividing by a fraction means keep the first number the same, multiply by the reciprocal. And look what happens here. You get 12/3, or if you simplified first, you'd get 4/1. Ta-da! So 4 ounces per 1 serving. And I want you to write all of your answers as a fraction with a denominator of 1, and make sure you label everything. Everything. All right, we've got 2 pools that are leaking. Yikes. If you have a pool, you know that it can get tricky if something happens to the liner. So here we are. We have pool A and you have pool B. Okay, pool A has leaked 2/3 of a gallon in or per 20 minutes. Okay, pool B has leaked 3/4 of a gallon. Oh, wait. I'm reading this wrong. Sorry. After 15 minutes. This one's 15 minutes. Pool B, it's after 20 minutes. Okay. Now, you have to make a decision here. Are you going to calculate your rates in terms of an hour, or are you going to do it per minute? You can do it either way. We just have to decide on what you want to do to be consistent. So if I go right here and say 2/3 of a gallon in 15 minutes, I kind of like hours better because that seems to make more sense. You could start building this one this way. 2/3 of a gallon in 15 minutes would mean, okay, and if I just kind of think of this as a table, that means in 30 minutes, which would be a half hour, this is twice as big. This would be twice as big. I'd get 4/3 gallon in 30 minutes. And then I could double it again to get 1 hour. Okay, that'd be 60 minutes, which is the same as 1 hour. Then this would be 8/3 of a gallon in 60 minutes. Okay, and if you wanted to, you could write it as 8/3 of a gallon in 1 hour. Now I've got a unit rate. If you don't like improper fractions, 8/3 is 2 2/3 gallons. Okay, you could think of it that way. If you like decimals better, you'd change it to 2.6 repeating. All right, let's see what's happening here. 3/4 of a gallon in 20 minutes. So I'm thinking of a clock. 20 minutes, 40 minutes, 60 minutes. Okay. So on this one, if I get 3/4 of a gallon in 20 minutes, in order to get to that 1 hour mark, I'd have to multiply this. I'd have to have 3 of these because that would give me 60 minutes. Okay, and then I could compare it to this guy. So we have to take 3 of these 3/4. 3/4, 3/4, 3/4. That'd be 9/4 of a gallon. Well, how much is that? Well, that's 9/4. 9/4 of a gallon in 60 minutes is 1 hour. That is 2 1/4. Can you tell right now which one is larger? 2 2/3 or 2 1/4? If you're still not sure, change it into a decimal. 2 2/3 is 2.6 repeating gallons per hour. 2 1/4 is 2 25/100 gallons in 1 hour. So, which one's leaking faster? Pool A. If you had to quick decide which one you're going to fix first, I would fix pool A first because it's leaking more water. Hopefully you could get some help so that you could do it all. All right, so unit rates have a denominator of 1. Unit rate, and let's do something like this, 1. And if I give an example of like miles per hour, okay? That's the big thing. So if you're traveling, say 60 miles an hour, you're always looking for that denominator of 1. Let's write per is your fraction bar. So if I say 60 miles per hour, per is that one. That usually is the word, that's the key. Sometimes they might say instead of per, they might say in an hour or something like that. And the other thing I want you to make sure you understand is that this also represents the operation division. All right, check Schoology for your assignment. And as always, may the force be with you.